Assalamualaikum. This is a video presentation for the assignment 2 Industrial Power Electronic EKE 3673. This assignment was designed based on a few criteria: 240 volt RMS with 50 Hz to produce a DC output 0 volt to 60 volt by using converter rate power 200 watt. And our output voltage ripple must not exceed 5%. Now, let's see how we calculate its parameter using theoretical calculation. First, peak input voltage. For peak input voltage, V peak equal to surge 2 multiple VRMS. We got approximately to 340 volt. For non-ideal full bridge rectifier, we use the calculation for the V supply plus with the 2 times the V diode, which is 65 plus 2 multiple with 0.8, and we got 66.6 volt. Now, calculate the transformer ratio. From this, we get number of turn equal to 5. By using this number of turn to calculate the secondary transformer peak voltage, Vs will be equal to the 68 volt, and for output voltage for rectifier, Vs equal to 66.4. For duty cycle for output voltage 60 volt, by using this equation, we will get duty ratio 0.918. For continuous current mode, IL minimum must greater than 0. Then, IL minimum by using switching frequency F equal to 20 kHz, and our load resistance is 10 ohm. Using this equation, L minimum will equal to 20.22 microhenry. So we choose L equal to 200 microhenry because it's greater than L minimum. For output capacitance, our ripple factor is R. So delta V naught will be divided with V naught. Ripple factor must be lower or same with 0.05. So we arrange the equation to calculate C value, which is 1.73 microfarad. So because of that, we choose 25 microfarad. Now, we need to get the value of the inductance current ripple, which is 1.25 ampere. And after that, calculate for the minimum inductor current and maximum inductor current, which is IL maximum is equal to 6.625 ampere and minimum inductor current is equal to 5.375. For average inductor current, we total up for the minimum inductance and maximum inductance current and divide by 2, we will get 6 ampere. And our output voltage current, by using all the parameters that we have been calculated, will equal to 0.25%.
Now we'll go to the simulation part. So the first one is about SMPS without PI controller. So we have 4 types of graph. The first one is VS. So this PS graph, and then we go to IL. This is IL, which is for inductor current, and then we go to diode current. So diode current will be like this, and then the last one, the most important, is V out. So this is V out graph, and then for the PI controller, we must create the block diagram like this first to get the plot to determine whether the PI controller that we use is in stable condition. So after many times of the try change the value of Ki and Kp, we get this stable plot, and then we use the value of Ki and Kp for this plot diagram. So the value of Ki and Kp we use in the PI controller. So this is the value of Kp, and then is value of Ki. And then this is the value for the signal, which is 60, because the input we use is 60. Okay, so the important for the SMPS PI controller is for to determine the V out. So this is the V out that I get for the SMPS with PI controller.